Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Guys, for quite some time, I was getting requests for making scenario-based videos. So I thought, okay, let me start incorporating some of those videos here. And here is one scenario-based video which I want to discuss, where people want to know that how can I configure a glue pipeline which can ingest multiple SQL tables. So let's get started. So just to explain the scenario here, so what we are talking about here is people sometimes try to do a volume ingestion from their databases. So for instance, in their JDBC data source, they will have 5, 10, 50 or 20 tables, and they want to create an ETL pipeline which actually can then read this data and can write into, say, in S3 bucket as a target as example. And in most scenario, I've seen people writing data to the S3 bucket. So people want to understand that if you are building this kind of pipeline where they want to read data from multiple tables into a database and want to write to different S3 bucket locations in the data lake, how can they create such a pipeline, and what to consider and what choices to make? And that's what I want to cover in today's video. So when you're trying to create such a pipeline which is trying to ingest data from multiple tables, roughly two big questions which come in the mind. First is, do you want to create a single pipeline or individual pipelines? That means, suppose, for example, I have got 10 tables. Should I create a single pipeline which is simply going to ingest data from all my 10 tables? Or should I create one pipeline per table? Okay, that's one key question people have to struggle with. And the second one is, end of day, the ingestion is done by a glue job. Okay, so question comes is that, should I create a single glue job or should I create individual glue job? So would one glue job per table will be a good consideration, or should I create a single glue job and reuse for all 10 different tables? So primarily these two things are the biggest puzzle points when you're trying to design a pipeline or glue job which is trying to ingest data from multiple SQL tables into your data lake. So let's try to go through this consideration a little in detail. So let's talk about the pipeline considerations. So for instance, individual pipeline versus single pipeline. What you need to consider. So generally people go for individual pipeline if they have different schedule for ingestion. So for instance, few tables they want to ingest in the morning, few tables once in a week, few tables once in a month, few tables daily in the evening or in the night. So if people go for individual pipelines only when they have different schedules for different tables. If you have the same schedule for all the tables, for instance, you do a daily ingestion from the table every day, or you do daily, or you do monthly ingestion or weekly ingestion, but all tables are bunch of tables, at least like 10 you do weekly, 10 you do monthly. So when you're doing a bunch of tables, you are actually ingesting at the same time in the same schedule. Then people go for single pipeline. So one of the things to consider is schedule, whether each table has its own schedule, or can bunch of table can be put into one schedule. Okay, that's one consideration. One way of deciding whether to go for individual pipeline or go for single pipeline. Now the second one is dependency between ingestion. So if you have a scenario where say if you're talking about individual pipelines, like for instance, like suppose you have 10 tables, but you want to first ingest 2 tables, then you want to ingest 3 more tables, and then rest of the 5 tables. If you have certain dependency like that, then in that case, generally people go for single pipeline, because setting such dependency in a single pipeline, and when I say pipeline, it's like a workflow, right? So in a workflow, you can set up dependency between activities. So if you have dependency between ingestion of different tables, some kind of sequence you have to maintain, then it's easy to maintain in single pipeline. In multiple pipelines or individual pipelines, you can do that, but it's a little challenging. So I have not seen like dependency is such a big thing, especially if trying to ingest the data. But yeah, sometime it might happen that you might want to ingest master table first and then detailed table, but I have not seen dependency is a big requirement. But technically, I want to put it here that if you have a scenario where you have multiple dependency, have dependency between your tables, then single pipeline makes more sense versus individual pipeline. And if you have a parallel ingestion requirement, which actually both can handle. So many times people say, hey, I have 10 tables, but you know what? I want to ingest all 10 in parallel. All 10 I want to do in parallel. That is possible with both individual and single pipeline. In single pipeline, you can go for multiple parallel executions. When you configure your multiple parallel ingestion jobs, ingestion activities as a part of the workflow. In case of individual pipeline, you can say, hey, these are my 10 pipelines. I'm going to run all 10 at the same time. So when you run all 10 at the same time, you get your parallel ingestion happening. So these are the regions why people consider single pipeline versus multiple pipeline. And one thing just stuck in mind, it's not in the presentation. One risk you have with a single pipeline, that if you want to run like whole pipeline, well, in a single pipeline, if the transaction fails in between, like for instance, you run 2 tables and on the 3rd table it failed, it can affect. So suppose like you are doing sequential ingestion, just as an example, and suppose after 3rd ingestion, the 4th table ingestion failed. In that case, your 5th, 6th, 7th, and 8th, and 9th, and 10th will not ingest. So that's a risk you carry when you're trying to use single pipeline. But if you have multiple pipelines, then in that case, since each of the pipeline is running independent, even if one fails, it fails individually. Other 9 pipelines can execute by their own. So that's the one thing I didn't mention here, but when I was talking, it stuck in my mind that, yeah, that's also one thing people have to consider. That single pipeline has a big blast area. So if it fails, then it can choke down the whole dependent activities in the flow, dependent ingestions in the flow. But if you have individual pipelines, then failing of one pipeline does not affect other pipelines. So those are thinkings you need to do when with the respect of your requirement to decide whether you want to go for an individual pipeline or you want to go for single pipeline. Then comes your job consideration, whether go for individual job or single job, because end of day, the ingestion is happening at the job level. Pipeline just does few more things in terms of like if you want to do cataloging or if you want to do some other activity after ingestion, then you create a pipeline. That's what you configure in your pipeline. But end of day, the task is done by a job, by a glue job. So the question comes whether you want to go for a single job or individual job. Here the decision is pretty straightforward. So you go for a single job when you have like standard transformation happening across all ingestions. So for instance, all you do in your job is read your data, convert into say Parquet format, and you write it. That's it. Or read your data, do some cleansing activity, standard cleansing activity, like convert your date time to some kind of format and those kind of things, remove any kind of empty row, and then you simply write to the destination. If you're doing this kind of thing, standard thing across all the jobs, then you can go for a single job. But if each of the ingestion has their own individual transformation requirement, then you have to go for individual job. So here the things are very simple. If they are standard transformation across all ingestion, single job is good enough. But if you have individual jobs, individual transformations per ingestion, then you go for individual jobs. Now I want to come down to one specific scenario now, because there are many other videos I have made, and there are available documentation, other videos you talk about, okay, how do I create a pipeline with jobs, single jobs, right? With the individual jobs. And I mean, even I have created a whole schedule on the whole videos on the pipeline using event-based, workflow-based, glue workflow-based, or step function-based pipeline. So those I'm not going to cover individual job and individual pipeline scenario, because like in depth, because that I have already covered in the other video. So here I want to take a specific scenario now where I create a single pipeline and I use a single job. That means for all those 10 tables, as example I talked about, I want to create a single pipeline for those 10 tables, and I want to do ingestion using a single job. So okay, if we have to design this kind of ingestion pipeline, how does the design look like? So basically, if you are using a single pipeline, single job, then you are talking about that means you're talking about you have a single ingestion schedule, because again the whole base premise is that you are trying to ingest multiple tables. That means those multiple tables has to be ingested at the same time. You might want to set up dependency between ingestion. Not a big requirement I have seen, but I thought I will cover it from the technology point of view, so like to the completeness point of view. Then you have parallel ingestion, very big requirement, where yeah, I have 10 tables, but can I ingest all 10 in parallel in a single pipeline? Literally, I want to run my pipeline, let 10 ingestion happen in parallel, and then probably 4 more, and then 3 more kind of things. So those kind of, but you want to have parallel ingestion happening in a pipeline. And finally, since it is a single job scenario I'm talking about, that means we are thinking that how do I do standardized transformation across all the jobs, across all the ingestion. So if this is the requirement, certain design things come in the mind. First thing is that how do I create pipeline with dependencies? Again, dependency and parallelism both. So taking first three items together, where I want to create a single pipeline where I can set up dependency, parallelism, whether I should go for glue workflow or should I go for step function, right? So again, these two, using glue workflow or step functions to create the pipeline, I have already covered in some other video, but we'll simply come back quickly on this topic, which one to use. Second one is that how can I configure my glue job to run concurrently? So now there would be a scenario where parallel ingestions are happening. 10 tables I want to ingest in parallel in a single pipeline. That means my glue job will we do a concurrent parallel run. How do I configure for that? And the last one, how do I standardize my transformation with a common code and parameterization? Because even if take a single scenario that, hey, I'm reading my data from the table, then I am converting into then I'm writing it to in a Parquet format to a destination. Still, there are few variables in place, like my table names are different, my database names could be different, my destination could be different. So people can have that kind of requirement, and in such case, how do I create a common code and parameterize it so that a single job can be used in my pipeline? So let's go through each of design things one by one. First thing, glue workflow or step function. Technically both can be used, but I will recommend to go for a step function, because you find that when you're trying to go for parallelism and dependency, it is much easy to manage in a step function than in a glue workflow. And plus, another thing which I have seen in ETL pipeline, it is not all about just running crawlers in glue job. people want to do some other activities as simple as sending notification about success and failure of your pipeline. For such things, you need to integrate with other AWS services, which is much easier to manage in a step function than doing the same in Glue workflow. So my recommendation is that if you're going, especially if you're going for a single pipeline configuration, try to use a step function. It is much easier. When I try to create individual pipeline, individual Glue workflow, individual pipeline for ingestion, probably Glue workflow is good enough, unless you want to like use other AWS services. But especially if you're going for single pipeline where you need to configure your workflow in a slightly more complex way, probably integrating few more services, probably trying for retry, failure, and those kind of things. So configuring such thing is much easier in a step function. And you can create a step function where you can call your orchestrate your Glue job in a certain dependency, in a certain parallelism. Again, it all depends on your business requirement. That do you want to set up dependency between ingestion? Do you want to set up parallelism in the ingestion? And if answer is yes, you can configure that in step functions very easily. Okay. So step function is my recommendation, especially if you're going for a single pipeline for a number of tables to be ingested. Now, how do I configure my Glue job to go for concurrent runs? Well, remember, my premise is single pipeline, single Glue job. That means one Glue job has to run in parallel to ingest my data. So how do I configure my Glue job to run in parallel? And that is pretty straightforward. There is a property in a Glue job called maximum concurrency. So that you can set to, and by default that value is 1. And that means only one, like that means Glue job can have only one instance of run. But here we are talking about parallel ingestion in my workflow. That means I want to run my Glue job, say, if you take example up to 10 tables, I want to run, for instance, all 10 ingestion in parallel. That means my Glue job will run in parallel for all those 10 tables. That means my concurrency has to be 10. So depending on your business requirement, how many times Glue job you see running in parallel in your pipeline or even across pipelines, in that case, based on that value, you can set up your concurrency. So if I'm setting a concurrency of say 6, for example, over here, that means this Glue job can roll at the same time 6 times in parallel, six instances in parallel. Okay. So concurrency setting you can use to make Glue job run in parallel in your workflow, in your pipeline. Then comes your standard transformation, and standard transformation is actually managed through basically the general guidelines, and I'll show you an example also, and I have a demo also to show you. But general guidelines is that you don't do hard coding, whether you're trying to mention the source table or destination or transformation information, partitioning information. Don't hard code those things. Parameterize those things so that when the pipeline is running the Glue job, they can simply pass this parameter to your Glue job based on the specific table they're trying to ingest. So the key is avoiding the hard coding or avoiding the even hard coding of configuration in the Glue job, so that your Glue job can be parameterized for specific ingestion in the pipeline, even in parallel. And then this Glue job can be run multiple times in the same pipeline with different set of parameters to simply do ingestion of a particular table in their part of execution. So again, I'm going to show you examples, and it will probably make more sense to you. But typical parameters typical parameterization people do is source database name, source table name, partition keys, destination location, data conversion format, whether it's going to be CSV or Parquet or JSON, compression value. All those things can be actually pretty much standardized, parameterized to make a standard Glue job. Now, if I take example over here, for instance, here I'm trying to parameterize certain things. So here I have in my glue job CDB, which is my catalog database name, which is my source database name catalog, source catalog database, my source catalog table, and then my destination location, say S3 bucket. So I'm simply I'm trying to avoid hard coding of my database name, table name, and destination location. And then what I do in my glue job code is that I read these parameters actually, and then these parameters are read, like what is my catalog database name, catalog table name, destination location, and then wherever in my glue job I need to mention these value, I simply pass it from my parameter values. So I don't hard code my table name or database name or destination locations, or even in this case I can do many more things. I can catalog format, I can catalog your compression algorithm, many other things can be. I can there's no partition key, but I can actually, if you want, I can also catalog the partition key. So the point here is that you can parameterize all these values into your glue job so that you don't hard code them. So the single job then can be used by pipeline multiple times, even in parallel, and all pipeline has to do is that pass these parameters to the glue job, and then voila, you are all good. And so this is and yeah, you can use the same job across your pipeline to get the job done. And this is the one I'm going to use for my example demo as well. Okay, so that's how you parameterize, and you avoid hard coding of configuration or coding to make your job reusable in your pipeline. So I'm going to build a demo, and for this demo, what I have done here is that I have got my Amazon Redshift as a source database, data warehouse database here. Well, I could have used a JDBC point, but already have one Redshift instance up and running with some data, so I thought I'm going to use that. It has got 4 tables: orders, customers, sensor data, and customer profile. Then we are going to use a step function with a single glue job to create an ETL pipeline, where I'm literally going to ingest all these 4 tables in parallel. So in my ETL pipeline, single ETL pipeline, I will reuse my glue job to run parallel ingestion of these 4 tables into 4 S3 bucket. So that's what I'm going to do in the demo today. So let's go to the AWS console to see how demo works. So here we are in AWS console. As I mentioned earlier, I have got a Redshift cluster which I'm going to use for my demo. So this Redshift cluster has got a couple of tables in place, and the 4 tables I am interested in is your sensor data. I have got this sensor data table over here. Then I have got orders, I have got customers and customer profile. These 4 tables I'm going to ingest in parallel. Now the destination location is I have tried to create a S3 bucket, say my demo data lake, where I have created 4 folders: customer profile, customers, orders, and sensor data for each of the table. And my ETL pipeline is simply going to write data to these 4 folders. So you can see here my customer profile folder, which is empty, my customers folder, which is empty. Here is my orders folder, which is also empty, and then here is my sensor data folder, which is also empty. So these are my source and destination. Now come to the glue job. So this is my glue job. I'm calling it JDBC data ingestion. This is like a single glue job, standard glue job, which I'm going to use. The first thing I want to show you is the job details. So few things in job details. If I come down here, you can see here, first of all, if I go to advanced properties, yeah, I have set maximum concurrency to 6 over here. That means I can run this glue job 6 times in parallel. Well, I have 4 tables. Well, I thought earlier I'll use all 6 tables, so I use 6, but then I choose to use 4 tables only. So yeah, first thing I have to configure here is maximum concurrency, and I need a value 4 or more because I am in my ETL pipeline. I want to do 4 table ingestions in parallel. So this is the first thing you need to configure. And then I have parameterized certain things. So you can see here, this is my CDB, which is catalog database name. So, well, I need to show you that as well. Okay, hold on a second. I'll go and show you that. Then here is my catalog table, and here is my destination location. So this is the destination S3 location. This is the source table name, and this is the source catalog database name. Now I need to show you something. So if I go to Glue, so what I have done is that the Redshift database tables I have cataloged. If I go to my Glue console, so this is my Dojo DB as my database name, and if I go and see the table, you can see all those 6 tables are actually listed over here. So these are my catalog of my Redshift databases. You can see all are coming from Redshift. So in this Glue job, when I say catalog database name, what I mean here is Dojo DB here. And when I say this is my catalog table name, what I mean here is these individual table name, which presents sensor data, customer profiles, orders, and customers table inside my Redshift database. So these I need to part, and when I say destination, I mean one of these folders, one of the folders for customers and orders where the data will be written. So this I have parameterized. So once I have parameterized that, then I need to see my code, and in this code I have avoided hard coding. So what I'm trying to do here in my code is that first I'm trying to resolve my parameters. Then I'm reading my parameter values, and then anywhere where I have to put a database name, I simply passing it through the parameters, table name, passing it through the parameters, destination location, destination S3 location, I'm passing through the parameters. So I'm trying to avoid hard coding and passing all those values through the parameter values. So that way I created a Glue job which my ETL pipeline can call multiple times with different parameters and make use of it, and I don't need to create those many individual Glue jobs anymore. A single Glue job can do my ingestion. So what I'm doing here in this example over here, I'm reading from my database table, then I'm simply writing to the S3 bucket. And to be honest, if you're trying to write an ingestion pipeline, generally people don't do much, simply read it. Sometimes people do some cleansing job like removing records with some missing values and those kind of things. And sometimes people do column renaming and those kind of things, and then after that they simply write in a specific format to the destination. So I have not used any transformation here, but you guys, once you have read the data in a data frame over here, you can apply some standard transformation on that data frame to simply to do some standard cleansing activity before you ingest it, and then simply write in a certain format, which is a Parquet format in this case. And now comes our ETL pipeline. So this is my ETL pipeline, a single pipeline JDBC ingestion workflow, which I have used a step function to create. You can see here I've tested it quite some time with success and fail both. So if I try to see how does my pipeline look like, so let me click on my edit here. I'm not going to edit, but I want to show you, and I use my workflow studio, and I remove this part. So you can see here, this is how my pipeline look like. So I have tried to achieve parallelism here. So I have created a parallel state, and then each of these parallel state have got more parallel states, and then in each of these parallel state, I'm simply invoking the same Glue job. It's the same Glue job, but one is ingesting order data, one is customer data, one is customer profile data, and one is the sensor data. So if I look at orders data, for instance, it's very important what parameter I'm passing to it. And if you can see over here in the parameters, I'm telling it that, hey, you have to run this job JDBC database ingestion, JDBC data ingestion job. Okay, so my job name is JDBC data ingestion. So I'm simply run JDBC data ingestion, and here are my parameters. So you can see DojoDB is my database, my table is orders, and then my location is my demo data lake orders bucket folder. If I change that to ingest customer data, everything changes here. Well, not everything, basically last two parameters change here. Now I'm reading from the customers table and I'm writing to the customers folder. If I go to the third one, I'm reading from the customers profile table and writing to the customers profile location. And if I go to the last one, if I go to the last one, and I have got my sensor data table, which I am simply writing to sensor data folder. As you can see here, my job is pretty straightforward, where I am simply my ETL pipeline, simply running 4 ingestions in parallel in a single pipeline using a single job, but passing different parameters. So what I need to go do now, I have to simply start the execution. So let me start the execution. I don't need to pass any. So when I run the execution, this pipeline is simply going to use this single job to run 4 times in parallel and ingest 4 database tables, populate 4 folders with the table data. So let me start the execution. I don't need to pass any parameter over here. And yeah, so execution has started. So let's wait till the execution finishes. And once the execution finishes, I'm going to show you the the final state of the workflow, and also I'm going to show you the data available at the output location. So let's wait till the ETL execution finishes. Okay, so you can see the execution has finished. All the 4 jobs has finished their job. So if I go to here, yeah, it has been successful. So if I go to my glue job here, and if I click on my legacy interface, and I select my glue job, you can see here that my jobs have run in parallel. Yeah. You can see that happened here. Now if I go to my destination locations, for instance, if I go to my customer profile here, you can see it is populated. I have got my data, same for my customers, same for my orders, hopefully, yeah, and same for my sensor data. So you can see that the pipeline has executed, and it has used a single glue job to basically run in parallel. So what I'm going to do, I'm going to provide you the code of the glue job as well as the JSON definition of the pipeline, both in a link in the link in the description box, so that if you want to reuse this content, you can reuse it and do some practice, some demo, some lab at your end. So yeah, that was all for today's videos guide. If you like the video, please click on the like button. Please subscribe to my channel. I always look forward to your feedback, whether it is for the new content or for any mistakes you want to correct, or for any kind of topic you want to recommend. Like this topic was recommended by one of you. I always look forward to your feedback for improvement, for new content. I promise to come back again in a week's time with another such a video. In the meantime, please stay safe and have a nice day. Bye bye.